Right, I was going to call this video Mr Mackay Speedruns the 2022 National 5 paper, but I thought this might be quite useful for you to be able to look back on during study leave. So you've got loads of questions, you've got the revision papers I'd written, you've got marking schemes, but sometimes it's more helpful to get an example of an answer. I've done this for the hires as well, and they seem to think it'd be useful. So first of all, I'm just going to do the systems questions. I'll fly through the paper, find the systems questions, and then we'll come back and I'll individually do each of the kind of bigger software development things. First of all, converting a binary number. So 60 into 8-bit binary. You see, I've already put my headings here for the 8 columns. So 128 and 64, they don't go into 60 anyway, so straight away they're going to be a 0. 32 goes into it. If I put 32 and 16, that makes 48. Plus 8 take me to 56. Plus 4 would take me to 60. And then I'll just fill in the remainders. So that's my answer. 0, 0, 1, 1, 1, 1, 0, 0. Going to go to question 5 and then come back and do software development later. So there's another number question in here. Cruising speed of a plane is 891.6 kilometers per hour. It'll be stored using floating point representation shown below. So we've got the 0.8916 times 10 to the power of 3. Identify the mantissa and the exponent. So we should know that our important bits are this and this. So my mantissa is 891.6. No 0 and no point. My exponent is 3. Then we're going to go to question 7. So we've got a vector graphic question. Now this is a little bit easier than the one that's in the 2023 paper. In 2023 you're told at least one of the objects and then you're asked for other objects. This one is just asking you the name of an object. So there's lots of objects we can pick. You've got ellipses up here. We've actually got the text as well. We've got polygons. I mean, this could be a polygon as well. So could that. We've got rectangle there. We've got the line across it. So there's lots of different objects on there. If I just pick ellipse. And then an attribute. Now my attribute is of that object. So it's got to be relevant to the object that I picked. So if it's the ellipse, the most obvious one would be the line colour, because I've got this big thick line. I could have the line thickness, could have the fill colour as well. Because you could say it's filled in white. So we've got one object and one attribute. And I'm going to go over to question 8 and just pick out one of the systems bits from this. So I'm looking for 8D. So an app, and it's not important at this point to know what the app is. The app is storing passenger information. State how the information can be transferred securely from the app to the computers. So how are you going to transfer something securely? You're going to use encryption. The 2023 paper, I think it's a question about an email if I remember right, and it's about what you would use for that, and again you would use encryption. Then there's a few of these in question 9. So we've got, first of all here, an ASCII question. The user enters this password below. State how many bits would be required to store the password using extended ASCII code. So I know that extended ASCII code has got 8 bits per character. And this is the password, so I need to say, right, the answer is not 8, the answer is like how many characters have we got here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. So I've got 10 characters, 8 bits each, so it's 80 bits. And that's my answer. There's another one in question 9, if we look at 9D. So after testing, this program is run without requiring any further translation, right? And I think the emphasis there is on further translation. So state the type of translators that have been used. So I've got 2 types of translator. I've got a compiler and I've got an interpreter. This program has already been translated because it says it's further translation and after final testing. So you translated it at least once to be able to run it. It says it doesn't require being translated after that. So they've translated it once, they tested it, found it worked, they don't need to go back and translate it every time. So it's a compiler. If this was an interpreter, you would have to translate it every time you run the program. But because they've tested it and they know it's fine, they don't need to translate it again each time. Just a couple of more systems ones. So 10b. We've got parts of the processor. So I'm going to highlight this. It's probably a little bit easier to do it with highlighter. So part of the processor, and this one is also part of the processor. And that's important because if we're talking about things like the data bus, for example, well, that's not actually part of the processor. It's part of the computer system, but it's not inside the processor. So the part of the processor that will perform a calculation once the program is implemented. So if we're doing a calculation, that is going to be the ALU. State part of the processor used to temporarily store something. So it's not memory because memory isn't inside the processor. Part of the processor that could temporarily store a value, that's the registers. Because the registers are this small amount of temporary storage. And then the last systems bit is over 10D. So this is a question about somebody who's like a flooring contractor, and he's working out prices for covering somebody's floor. He takes a picture of the floor and the images are stored as bitmapped graphics. So we've already had vectors elsewhere in the paper. So describe how a bitmap would be stored. Now we've got two things to say about it. I've given you a kind of verbatim answer that you could use for this. What you need to be saying is that each pixel has a number, right? It's stored as a binary number. So the way that we've generally done it is bitmaps are stored as a grid of pixels. Each pixel has a binary number representing the colour. And then lastly, a way that Sam could reduce energy consumption of the tablet. So there's lots of things that he could do here to reduce energy usage. The most obvious one is just that he could turn down the screen brightness because it's a tablet. When you think about it, you would do that on your phones. So turn down the brightness. So that's all the systems questions. What I'm going to do is go back and go through some of the software development ones, some of the short ones together, and then some of the kind of bigger code and design questions on their own so that you can look at them individually if you want an example of input validation or of running total or something like that.